Okay, so today's lesson is continuation from last video. Last time we talked about volume, disk method around the x-axis. This time we're going to talk about the washes method around the x-axis. Washer method, you could think it as two disk method. The smaller disk is getting subtracted from the bigger disk, forming a hole within the bigger volume, in this case a cylinder. So washer method is taking a smaller volume and you're subtracting it from the bigger volume to create a hole in between. So the formula will be same thing as the disk method, which is a pi r squared times W minus a pi r squared W also. The first one being a capital R for indicating a bigger radius. Second one indicating with the lowercase r for the smaller radius. Again, if you put them into integral, it'll be pi times the range from a to b with r of x squared minus lowercase r of x squared dx. Okay, so let's look at our first example. Find the volume of the solid formed by the revolving the region bounded by the graph of f of 3, f of 1, x equal to 1, x equal to 3 about the x-axis. So if you look at the graph, we're looking for the area from x equal to 1, x equal to 3, and basically a y equal to 1 and y equal to 3, which is a red rectangular shape. And we're going to rotate this about the x-axis. So notice that if you're rotating that rectangular region, we have a little gap in between the area and where we're rotating the x-axis. That's going to create a volume known as a washer method, because you're going to have a hole in between area that you want to find the rotating to the axis of rotation. So let's look at the bigger radius from the top of the function to the axis. You're going to have a cylinder, which is known as your big radius. And in our case, the big radius is equal to 3 minus 0. 3 being your top of your function of the area to the axis of rotation. Now, the smaller radius will be the gap that you'll be subtracting. In this case, this cylinder. And our smaller radius will be bottom of the area, which is 1, to the axis of rotation, which has happened to be 0. So if you rotate them around and subtract it, you're going to have a cylinder that has a hole in between. Let's calculate the volume. So we said the washer was pi times a to b of r of x function, which happened to be a radius function, square minus smaller radius function dx. So our volume will be, finding it from 1 to 3. Don't forget the pi in it. Let's bring our pi. Your bigger radius was 3. Your smaller radius is 1. Dx. So your volume will be pi times integral from 1 to 3 of 8 dx. And if you integrate 8, you will get 8x. And you're evaluating this from 3 to 1. You will get 24 minus 8, which you're going to get 16 pi as your volume of the cylinder. Now let's look at the second example. Find the volume of the solid formed by revolving the region bounded by the graph of f of x equal to x to the third, f of x equal to 1, x equal to 1, and x equal to 5 about the x-axis. So if you look at the graph that's provided, basically we're rotating that red region about the x-axis. Once again, if you look at the area to where you're rotating, there's a small little gap right here. So because of that gap, we know this is a washer. So once again, let's try to figure out big radius. Big radius will be top of the area to the rotation, and our smaller radius will be the gap. So this will be your smaller radius. Our big radius is going to be x to the third minus 0. Your smaller radius will be 1 minus 0. So our volume will be pi from 1 to 5 x to the third square minus 1 square dx. Volume will be pi integral of 1 to 5 x to the 6 minus 1 dx. If you integrate this, you're going to get x to the 7 over 7 minus x, and you're calculating this from 5 to 1. And if you evaluate this, you're going to get 78,096 over 7 times pi. To summarize the washer method has a gap in between the area that you want to rotate to the rotational axis, unlike a disk method. So your goal is to figure out what will be the bigger radius, your bigger radius being the top of the area to the rotational axis, and also finding the smaller radius. Your smaller radius is what you need to subtract, which is your gap. So what is your top of the gap to the rotational axis? Put them together. Your washer method is pi times integral of a to b, bigger radius square, minus smaller radius square. We'll calculate the volume using the washer method.